Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to talk about aggregated API servers. What are Kubernetes aggregated API servers and why would we want to use them? So we already know that Kubernetes is very extensible system. There are a lot of ways using which we can extend our Kubernetes cluster. One way that we have already looked into is CRDs. So if we want our Kubernetes cluster, Kubernetes API server, to support a specific resource that is not already supported, we can register that resource using custom resource definitions or CRDs. I have already made a video on CRDs. I will link that somewhere in the description. You can watch that as well. So CRDs are one way to extend your Kubernetes cluster. The other way using which you can extend your Kubernetes cluster is aggregated API servers. So for example, if you, let's say, extend your Kubernetes cluster to add a custom resource using CRDs, in that case, that resource is going to get served by the main Kubernetes API server. So for example, let's say if you introduced another resource named cluster, let's say this cluster resource, Kubernetes resource, was added using CRDs. In that case, this cluster resource is going to get served by the main Kubernetes API server. Similarly, we can write aggregated API servers, and these aggregated API servers can also serve resources from specific group and version. So if you remember how we register custom resources using CRDs, we also specify which particular group and version the new resource is going to be part of. Similarly, we can also specify the new aggregated API server that we are going to write, which particular group and version this particular API server is going to be responsible for. So which particular the resources that this particular API server is serving, which particular group and version those resources are going to be part of, let's say. So this is the very, very basic definition of aggregated API server. Now, aggregated API servers are, so CRDs, like we discussed, these are the two ways, but there are a lot of limitations when we try to extend Kubernetes API server using CRDs. But in case of aggregated API servers, we hardly have any limitation because, as I said, we are actually writing, let's say, almost similar API server like the main Kubernetes API server. So it hardly has any limitations because we can have the things, we can code the things the way we want to. If we talk about what are the differences between CRDs and aggregated API servers, so one of the main differences that I can think of is, for example, let's say in case of CRDs, we don't have any, we just have two sub resources. So if we talk about sub resources, in case of CRDs, we can just have two sub resources. One is status and another one is scale. So when we, again, if you remember my previous videos, we have already talked about what are sub resources, why do we need them. And so we are not actually going to define sub resources here. But if we talk about CRDs, in case of, let's say, if we register a new custom resource, this particular custom resource can just have two sub resources, status or scale. So that is another problem. If we want to have, if we want this custom resource to have another sub resource, we cannot have that if we are introducing this particular resource using CRDs. The other problem that we can think of is, when we try to introduce a resource using CRDs, the data store is always going to be etcd. That's not a problem. But if you want to have another data store, to store your custom resources or new resources. In that case, you cannot do that if you are introducing the resources using CRDs. The other problem that I can think of is in case of CRDs, we don't have inbuilt support for cohabitation. So, for example, let's say if we talk about, we know that in case of Kubernetes, a particular resource from a group can reside in more than one versions. So, for example, let's say ingresses were part of, let's say, extensions v1 beta 1, or that's not a good example. Uh, let's talk about a resource that is in, let's say, v1 beta 1 and v1 version as well of a specific group. So for example, let's say there is a resource that resides in v1 as well as v1 beta 1 version of a particular group. In that case, if we use CRDs, the conversion of resource between those two versions is not seamless. We will have to introduce conversion webhooks to actually convert the resource from one version to another version. So that is another problem if we introduce the resource using CRDs. The other problem that I can think of is custom grace period deletion. So for example, let's say if we want to delete a particular resource, but we want to forcefully delete a particular resource, we cannot do that if that resource is introduced using CRDs. So for example, if we, let's say, try to delete a pod and we look into help, we would be able to see the grace period here somewhere. And this grace period, as you can see, grace period of time in seconds given to the resource to terminate gracefully. We This particular grace period is supported in case of pod because pod is being served from the actual API server. But if we introduce a resource if we introduce a resource using CRDs, in that case, we cannot have custom grace period deletion. So that is another problem that I can think of. The other problem is if we try to introduce another resource, and we know that we have already talked about, if we introduce this resource is going to be served using main API server. So this also increases load on the main API server. So these are some of the problems because of which CRDs are actually not able to achieve the things that Kubernetes aggregated API server can. Now let's look into aggregated API servers and see how these things are actually resolved or supported. So in case of API servers, if we, let's say, introduce another resource cluster, we can have any number of sub resources apart from status and scale. So for example, if we want to have, let's say, any sub resource, let's say get kubeconfig or something like that. In that case, we can have that sub resource if the main resource is introduced via API server. If you try to go into a bit more detail, if you did not understand this sub resource thing, uh, some of the examples of sub resources are, for example, logs for pods. So pod is main resource, logs, yeah, logs is sub resource for the pod resource. Similarly, let's say port forward, exec, etc. So those sub resources are supported because the resource pod is served from main API server. But if we serve a resource using CRDs, in that case we will not be able to support any sub resource other than status and scale. So that is one thing that can be achieved if we are using aggregated API server. The other thing is we can use any data store. We can also use HCD, but not the one that main Kubernetes API server uses. So we have that flexibility as well. Uh, Cohabitation. So because we are writing aggregated API server, we are going to handle how the objects are being served. We have the ability, we have the privilege to make that conversion happen, that we were not able to do, what we were not able to do in case of CRDs. The other thing is graceful deletion. So again, because we are writing the API server, we will be able to support the grace period for the newly introduced resource. Uh, we will not be increasing the load on the main API server. And the reason is because we are writing a brand new, let's say, API server called, and we name it aggregated API server. So the load is not actually increased on the main API server. The other thing is, for example, let's say we have introduced a resource, but I want some custom validation on that resource before it's actually created on cluster. So in that case, if the resource is introduced via CRDs, we will have to write validating webhook controller to actually validate that resource. We cannot have custom validations in case of CRDs. We can have schema, we can have schema level validations, for example type of the fields, etc., but we cannot have custom validation. To have custom validation in case of CRDs, we will have to write our own validating webhook controller. Again, we have already covered that previously. But in case of aggregated API server, while the resource is being created, because our the API server that is going to handle creation of the resource is written by us, we can have any custom validation logic that we want to. So these are some of the reasons, or these are some of the differences between CRDs and aggregated API servers. Now, if we try to talk about in which particular situations you would want to use aggregated API servers instead of CRDs. So now that we know the differences, you should be able to make that distinctions. You should be able to take that decision. But some of the things that I know of are, for example, let's say you have to support more than one API version for a particular resource. So if you are introducing a resource on your Kubernetes cluster and you want that resource to be available on two versions, let's say initially in V1 beta 1 and then to V1, in that case, to make sure that the conversion happens seamlessly, users are not affected, you would want to use aggregated API server. And the other reason is, if you want to have some complex validation on the resource itself, in that case you can try to use aggregated API server, because as I said, because the resource creation request is going to go to our newly written aggregated API server. In that case, we can have any custom validation logic for that particular resource. So if these are the things that you are trying to achieve, in that case, you can obviously try to go with aggregated API server. So the other thing that I want to talk about is how the request is actually handled in case of aggregated API server. So this diagram is from the book Programming Kubernetes. So yeah, if you want to get into more detail, you can obviously read the book. But if you see here, this is the main Kubernetes API server. And in here, we see the request is coming to first authentication, authorization. Obviously, there are some other steps here. For example, let's say auditing, etc. And then the next step, next component is kube aggregator. And this is the component that actually checks if the request that is coming to API server should actually be served by aggregated API server, or it should be forwarded to main API server. So again, let me summarize this. So when a particular request comes to Kubernetes API server, main API server, it goes through some of the components or some of the steps, let's say, and those steps are authentication, authorization, let's say auditing, etc. And then the other step is kube aggregator. Kube aggregator is the component, let's say, that checks if the request that is coming, when I say request, I mean, let's say create a resource or get a resource. So if that request should be handled by a custom API server or aggregated API server, or that request should be handled by main API server. And once Kube aggregator has made that decision, that request would either be forwarded to aggregated API server or Kube API server. Now, the question is, how does Kube aggregated figure out where the request should be forwarded to? So the thing is, when we register an API service, or let's say when we create a Kubernetes aggregated API server, we register that API server with main Kubernetes API server by creating an API service resource. So if you remember from the previous videos, when we create a validating webhook controller, we register that validating webhook controller with Kubernetes API server using a particular Kubernetes resource called validating webhook configuration. Similarly, when we create a Kubernetes aggregated API server, we register that on Kubernetes cluster or Kubernetes API server using another Kubernetes resource called API service. And we are going to look into API service in just a bit, but API service is the resource that registers our aggregated or custom API server with main Kubernetes API server, and it also explains which particular group and version this particular aggregated API server is going to serve. So for example, if I register an aggregated API server that serves resources from group viveksin.dev and version v1 beta 1. So we specify that while registering aggregated API server. So now Kubernetes aggregator knows which particular group and version this particular API server is responsible for. And that is how this Kube aggregator decides whether the request should be forwarded to aggregated API server or it should be forwarded to the main API server. So again, if I try to go into a bit more detail, so if, for example, request comes to Kubernetes aggregator, in that case, Kubernetes aggregator actually looks at the resource path. Uh, if you have watched my previous videos, you should know that Kubernetes API server is just, let's say, very well written RESTful application. So resources come to, let's say, slash API slash API slash group and then version and then resources, things like that. So from this particular resource path, we would be able to figure out group and version. So this is how a typical resource looks like. So let me show that to you very quickly. So get pods-v6, and if you see here, this is how a particular request looks like. So API, so API v1 and the namespaces, because pods are part of core, that is the reason we don't see core there. Otherwise we should also see, let's say, this is actually version for namespaces. So by looking at this particular, if you see here, by looking at this particular resource path, Kube aggregator can actually figure out which particular group and version the coming request is targeting, let's say. And once Kube aggregator is able to figure out the group and version from the request, obviously it would be able to figure out whether the request should be forwarded to main API server or aggregated API server, because when we create API service or when we register aggregated API servers using API service, we also specify which particular group and version that aggregated API server is going to serve. So yeah, this is how This is how the request is handled using in main API server. Now this kube aggregator doesn't actually know what are all the resources that are served by aggregated API server, and the reason is it doesn't have to know about all those resources. It should just be able to make the decision whether the request should be forwarded to aggregated API server or main API server. And it can do that by looking at the resource path. Now that we know about that, let's go ahead and try to look into how exactly we can register a particular aggregated API server with Kubernetes. So we have already talked about aggregated API servers can be registered using API service resource. API service API service resources are part of API registration group and V1 beta 1 version. These are some of the standard fields. For example, we can specify name, and group is the group that our aggregated API server is going to be responsible for. So for example, let's say I want my aggregated API server to serve the requests that are coming for group Vivek saying.dev, let's say, and version v1 beta 1. In that case, this is how I'm going to specify group and version. Now we know that we have already talked about we have already taken an analogy of mutating or validating webhook controllers. When we write a validating webhook controller, we just write an application and we try to register that with actual API server. And the exact same thing happens here again. We write the aggregated API server, we deploy that in our Kubernetes application, or let's say outside of Kubernetes cluster, and then we have to specify that application using this service. So this can either be cluster IP kind of service, or it can also be, for example, if our application is deployed outside of cluster, if our aggregated API server is deployed outside of cluster, in that case, we can also leverage external name kind of service. So I think this is again self-explanatory, I would say. Uh, we deploy aggregated API server, we expose that using a service, and that service is referenced here. CA bundle and insecure skip TLS verify. These two fields are used to authenticate the service that is being registered. If somehow we are not able to specify CA bundle, we can set insecure skip TLS verify to true, but in production scenarios, it's not recommended to use this field to be true. Now, these are the two things that are I would say very, very important. So let's say we have n number of groups, and there are some resources that are common between those two groups. In that case, how are we actually going to specify, how are we actually going to figure out which particular group should be prioritized? And that is where group priority minimum comes into picture. So as the name suggests, this number is the minimum priority of that group. And if there is another group with more priority than this number, in that case, obviously that group is going to get referred, or sorry, preferred, if we try to get the resource from a client, let's say, even from kubectl or any other client. So that is what this group priority minimum field specifies. Let's say again, if you have, let's say, two groups, and you want to give preference to a particular group from another group, in that case, this is the field that can be used. We are going to talk about it a bit more in just a second. Now, if we talk about, let's say, version priority, so now we also know that a resource can be in different version of the same group. So for example, let's say our resource is part of v1 and v1 beta 1 version from a particular group. In that case, which particular version should be preferred, v1 or v1 beta 1? That is what we can specify using version priority. So for example, let's say if we have to register another version for the same group, so vivek but we have to register another version, that is, let's say we have to register v1. In that case, we can also specify, or we can specify version priority for that version to be either greater than 20 or lesser than 20, and based on that value, a specific version is going to be prioritized. Let's say we registered v1 beta 1 and we also registered v1. So for v1 beta 1, we have specified the version priority to be 20. But for v1, if we specify version priority to be, let's say 10, in that case, for group viveksingh.dev, if we try to figure out the preferred version is going to be v1 beta 1. This doesn't actually happen. It's just a hypothetical example. In actual scenarios, v1 is going to be preferred, but this was just an example. So this is the significance of version priority. If you want to actually dig a bit more, how and when this was introduced. So this is the issue that was raised in 2017. So if you see here, for API group for RBAC authorization K8S.io and version v1, there were actually two versions that were supported, v1 alpha 1 and v1 beta 1. And if you see here, preferred version was being returned as v1 alpha 1, and this is wrong, because semantically v1 beta 1 should be preferred from v1 alpha 1. So this was the issue that was raised, and these two fields were introduced as part of fix to this particular problem. So this is the PR that was raised to fix that problem, and these two fields are, if you see here, these two fields are added as part of the PR to that problem. So again, if you want to figure out more, you can, I'll link these PRs and issues in the description, so you can check that as well. The other thing that I wanted to talk about is show you very quickly. So if you see here, we see there are two versions for this particular group, v1 and v1 beta 1. And if you see here, v1 is being preferred, and the reason is, whenever we registered this particular group and version, the version priority that we specified for v1 is greater than v1 beta 1. And this is why for preferred version we are able to see the version to be v1. For the Kubernetes native resources, you can look into this particular source file. This is Kubernetes code base. If you see here, we can see the group and version priority for all these resources. Now that we have discussed about group priority minimum and version priority, let's go ahead and actually look into. So by looking at this diagram, we know that Cube aggregator is able to figure out whether the request should be forwarded to aggregated API server or main API server by looking, because it knows which particular group version a new aggregated API server responds to or serves. And by looking at the API service object, Kube aggregator will be able to figure out if the group version, requested group version is supported by aggregated API server or main API server. And based on that, it forwards the request to respective component. Now let's look into a bit more into aggregated API server. So this is how, again, this diagram is from Programming Kubernetes. If you want to get into more details, you can obviously go through that book. So if you see here, we from this particular diagram, Cube aggregator forwarded the request to custom API server or aggregated API server, and it again, if you see here, goes through all that, all those components. So for example, authentication, audit, impersonation, authorization, and once all these things are done, it is forwarded to the actual logic that we have in aggregated API server. So if you see here, this aggregated API server looks very similar to the main API server here. There are just some differences. One is, again, we will not be able to, this aggregated API server wouldn't have any cube aggregator, if you see here. So we don't have any cube aggregator, because it is actually the aggregated API server, and cube aggregator is part of main API server. And the other thing is, so we know that, yeah, sorry about that. Internal of aggregated API server actually looks very similar to the main Kubernetes API server. The only problem is we don't have cube aggregator, because it's aggregated API server, and it doesn't have to figure out if the request should be forwarded to main API server or any nested aggregated API server. That is the reason it doesn't have cube aggregator. And it also, because it's aggregated API server, it also won't have the component that figures out or that serves the custom resources that are introduced using CRDs. Again, that's part of main API server. That will not be part of the aggregated API server. Now, if you look into the handler chain here, if you see, first initially authentication is done, and because this particular request is coming to aggregated API server from main API server, it simply means that the request is already authenticated. And when the request is already authenticated, even though the request is already authenticated, aggregated API server tries to authenticate that request again, and it looks at two header fields. So main API server authenticates the request and sets two header fields, X remote user and X remote group. I think that's the name. We will have a look into that in a bit. So it looks into that those headers, X remote user and X remote group, and if it finds those two header fields, it simply means that the request is coming from main API server, and the request is actually authenticated. Now the problem is, even if we have aggregated API server as a server running on the cluster, so we can directly call aggregated API server specifying those two header fields. And I mean, any let's say malicious component, any user, any program that is not supposed to call our aggregated API server can actually set those two header fields and then call the aggregated API server. That is the reason what happens is, Aggregated API server actually looks at a particular config map from kube system namespace and then actually verifies the client from a CA file that is specifies in that config map. Again, let me try to summarize it. So the request is coming to aggregated API server from main API server, main Kubernetes API server. That simply means that the request is already authenticated. And because the request is already authenticated, main Kubernetes API server sets two header fields, two fields in header, x remote x hyphen remote hyphen user, x hyphen remote hyphen group to specify username and the group the user is part of. But that is not sufficient for this aggregated API server to trust the caller, because any caller, any application, any program can call aggregated API server by setting those two fields in the header. And that is the reason aggregated API server takes help from this config map that is present in kube system namespace. So extension hyphen API server hyphen authentication. And if we look into the details of this config map, so if you see here, request header client CA file, this is the client CA using which client is verified from aggregated API server, even though these two remote even though these two fields are set in the header of the incoming request. So this is how aggregated API server authenticates the request again. After authentication is done, the next step is audit. In case of auditing, we do validation, but validation of the metadata of the resource. Actual validation of the specification of the resource can be done as part of the API server logic. And then the other thing is authorization. So once authentication is done, we will have to also verify if the user is actually authorized to perform that operation. And again, we know that this can be done using RBAC. So I have already created a video on our RBAC. I'll link that down somewhere. So again, aggregated API server sends another request to Kubernetes API server to make sure that the user is actually able to perform that operation or not. Or aggregated API server calls API server, main API server again to make sure that the user is authorized to make that particular operation or not. So this authorization is done using subject access review resource that we are going to look into in just a bit. And in case of authentication, we have already seen that the client is verified using client CA that is specified in the config map. And the other option that we have is token review. So token review by default is disabled, but we can enable it, and token review is going to be actually enabled when we, for example, write aggregated API server. There might be ways to write aggregated API server, but let's say when we try to implement it, we are going to use the same that we used for validating webhook controller, and that is actually being used to write main API server. So again, if I try to summarize authentication and authorization again, even though the request is coming to aggregated API server from main API server, the request is authenticated, and there are two fields that are set in the header, x remote user and x remote group. Aggregated API server cannot actually trust the caller, because any caller can set those fields in the header and call aggregated API server. And that is the reason the aggregated API server uses config map named extension API server authentication from kube system namespace to actually authenticate the client. The other mechanism that can be used to authenticate the client is token review. This is disabled by default. I'm not actually very confident about it right now, so that is the reason I'm not gonna talk about token review as of now, but token review is another mechanism using which client can be authenticated. Authorization is a way to actually figure out if the user is authorized to perform that operation. We know that Kubernetes pretty heavily uses RBAC. So in case of authorization, aggregated API server sends a request subject access review type of object back to API server to figure out if the user is actually authorized to perform that request or not. And then API server responds back by setting the status of subject access review to make sure or to specify if the user is allowed or not. If we look into the subject access review, if you see here, this is how this is how this is how subject access review resource looks like. So this is the resource attributes. I mean, these things should be familiar to you: group resource version and operation. So we are trying to create deployments in default namespace with name example, and aggregated API server is trying to figure out if this particular operation is allowed or not. And it aggregated API server calls main API server with this particular subject access review object, and then API server responds back with the same object, but by setting status field. So if you see in status field, we have allowed to be true, denied to be false. It simply means that this particular request can be allowed or is allowed. So this is basic RBAC stuff that main API server does, and aggregated API server uses main API server to figure that out. Now, there are chances that in some cases, main API server is not able to figure out the authorization, whether this particular request is allowed to move forward or not. In that case, both of these fields are going to be false. It simply means that API server was not able to figure out if the request is valid or not, and in that case, our main or our main logic of the aggregated API server is going to authorize the user with some other authorization mechanisms apart from RBAC. So that's also possible that the API server sets both of these fields to be false. And in that case, as I said, our custom aggregated API server is going to have its own logic to make sure if the request should move forward or not. I think, yeah, this is pretty much it that I wanted to talk about. So I'm just looking at if there is something else that was missed. Yeah, the other thing that I wanted to show is this particular config map is available on all the cluster, at least all the clusters that I know of. I have set up this cluster using kind, so we are able to see this config map. But if we look into other cluster that I have set up on DigitalOcean, so this is the cluster that I have on DigitalOcean. If we get config map from Cube system namespace, we should be able to see that config map available here. And this config map, so what I'm trying to say is this config map is available on most of the clusters. So get cm from Cube system namespace, and this should also have those client CA file, etc. The other thing that I wanted to talk about is the while authorizing the things, we make a request to main API server with subject access review. The result of these requests are actually maintained in cache as well in aggregated API server, just to make sure that we are not calling main API server too frequently. So we also have a cache maintained that has results of this particular request. So yeah, I think this is pretty much it. If you liked the video, if you think this is going to be helpful to your friends, your colleagues, share it with them. If you liked the video, hit the like button, subscribe the channel, and thank you so much. I'll see you in the next one.